Hello guys, in today's video we're talking about integration. Now what is integration? Integration is the reverse of differentiation. We are changing a derivative of the function back to that function. It means that you're integrating. Now integration can be used in different ways. It can be used in summing up something to form a whole. The opposite goes for differentiation. That differentiation can be used in breaking down something that is a whole into smaller parts. Integration can be denoted by this symbol. This can be denoted by this symbol. So anytime you see this symbol, it means that you're asked to integrate. So for a function, say f of x, which is the same as, okay, for a function f of x, let's say y is equal to f of x. And we differentiated this function and had the y over the x, giving us f prime x of it. So we are having the y is equal to f prime x dx when this one goes here. So now, for us to change the derivative of this function back to the function, we have to integrate. So we'll have this sign, integral sign, and integral sign here. So this integral sign is cancelling out the differentiation sign. So we have this will cancel this. So we'll be left with y is equal to f of x plus c. So that's what we have. So we have two types of integration. We have definite integrals and indefinite integrals. Definite integrals have boundaries. What I mean by boundaries, if you have integration sign with numbers on the top and the bottom, this is called the upper limit, while this is called the lower limit. And you have a function here. It means that what you're going to do there is what you have there is a definite integral. But if you have an integration sign without any numbers on the top and the bottom, it means that you have an indefinite integral. Indefinite integrals do not have upper limit or lower limit. So now let's go into the rules of integration. As we had the rules of differentiation, we also had the rules of integration. Power rule also goes for integration. So for integration, if we want to integrate a function with a power, say x raised to power n dx. Integrating it, you are going to have x raised to power n plus 1 all over n plus 1 plus c. We should always add our plus c. C means the constant. When we are integrating a variable with a power, this is what we have. So now let me give you an example. Example of this is integral of x to the power 5 dx. So we are asked to integrate this. Now what do? First, you have to identify the rule that we are meant to use. Since this variable is raised to power 5, it means that we are going to use power rule. So using power rule, we say that for us to use power rule, we'll add 1 to the power and divide it by the power plus 1. So we have x raised to the power 5 plus 1 all over 5 plus 1 and our plus c. So leaving us with x raised to the power 6 all over 6 plus c. So that's our answer. So another example is if we have integral of square root of x dx. We are also going to use power rule here because we can make x to have a power using indices. So we have integral of x to the power 1 over 2 dx, giving us x to the power 1 over 2 plus 1 all over 1 over 2 plus 1 plus c. So we'll now be left with x to the power 1 over 2 plus 1 will give us 3 over 2 all over 3 over 2 plus c. So we now have x raised to the power 3 over 2 divided by 3 over 2 plus c. So we now have x raised to the power 3 over 2 times 2 over 3 plus c. So leaving us with 2 over 3 x raised to the power 3 over 2 plus c. That's our answer. So this is for power rule. So now the next tool that we have is constant tool. Like we had in differentiation, we had constant tool. Also in integration, we also have constant tool. Constant tool is used when we are integrating a constant. So if we have integral of constant, say k is the constant. So k dx. Integrating this, what we are just going to do is that we'll add x to it since we are integrating with respect to x. So to integrate the constant with respect to that variable, you just add the variable to it, multiply the variable to the constant. So we have kx plus c. So an example is integrating 13 dx. Integrating 13 dx. Integrating 13, we have 13 x plus c. Always add your plus c. So another example is integral of 1 over 5 dx. We'll now be having 1 over 5 x plus c. So it's as simple as that. So now we'll go to the next tool. The next tool is sum and difference tool, like we had in differentiation. Sum and difference tool is used for polynomials when we have two functions separated by plus or minus. We are going to use sum and difference tool. So let me explain what I mean by that. So if we have integral of, say, f of x plus or minus g of x dx. So this is a polynomial. A polynomial, what I mean by polynomial, we have some polynomial is something like x squared plus 3x plus 5, x cubed minus 4x squared plus 6. These are all polynomials. You see, there are operators in them, plus or minus. So this is what I mean by polynomials. So when we are integrating all these kind of functions, we are going to integrate them singly. We integrate them individually. So we have integral of f of x plus or minus integral of g of x dx. So what I mean by that is that when you want to integrate this now, we have to integrate each of them, find the integral of each of them, and now join them back together. So that is what I mean. So now an example is integral of x squared plus 3x plus 6 dx. So for us to integrate this, we have integral of x squared plus 3x plus 6 dx. So we have integral of x squared dx plus integral of 3x dx plus integral of 6 dx. So we'll now be left with integrating this, we use power rule. Integrating this, we use power rule. Integrating this, we use constant rule. So now we have x squared plus 1 all over 2 plus 1 plus. Now this for this, we are going to bring the constant out so that it's not going to cause us problem. So we can just put this as 3 here. So we have 3 into this x raised to power 1. So we have x raised to power 1 plus 1 all over 1 plus 1 plus. Now this is a constant, so we'll just add x to it, 6x plus c. So this is giving us x cubed all over 3 plus 3x squared over 2 plus 6x plus c. This is our answer. So that is how to solve for sum and difference rule. So the next tool we have is constant times a function. So what I mean by constant times a function is when we have integration of a constant times a function f of x dx. For us to integrate this, we are going to bring out the constant. So we have k integral of f of x dx. So we'll bring out the constant and integrate the function. So now an example is integral of 5x squared dx. So for us to integrate this, we are going to bring out the constant. So we have 5 integral of x squared dx. So we'll now be having 5 into x is equal to 2 plus 1 over 2 plus 1 plus c. Always add your plus c, very important. So we have 5x is about 3 over 3 plus c. So this is our answer. So another example, integral of 3 all over x squared dx. So we bring out our constants. We have 3 integral of 1 over x squared dx. So we have 3. Now we are using power rule here. Raised to power integral of x to the power minus 2 dx. So we have 3 bracket x to the power minus 2 plus 1 all over minus 2 plus 1 plus c. So we have 3 x to the power minus 1 over minus 1 plus c. So we have minus this minus 1 multiply this, we have minus 3 into x to the power minus 1 over 1 plus c. So x to the power minus 1 is the same as 1 over x. So we have minus 3 over x plus c. So that's our final answer. The next rule is, this is just something that you need to know. When we are integrating the inverse of a variable or an unknown that we are integrating. Okay, let me say we have integral of 1 over x dx. So we are integrating the inverse of x, that's 1 over x. Integrating this, we'll be having ln x plus c. So the same goes for if we are integrating 1 over a dA. Be having 1 in ln a plus c. The same goes for if we are integrating 1 over y dy. We'll have ln y plus c. So anytime we have the inverse of a variable or an unknown, we have ln of that variable. We have the sixth one, which is the last. When we are integrating exponential ax dx. Integrating this, we'll be having e exponential ax all over a plus c. So anytime we are integrating an exponential and that is raised to power something, this is what we have. So an example is integral of exponential 3x dx. So we'll be having exponential 3x over 3 plus c. This 3 all over this 3 plus c. So we have another example. This example 1, example 2, exponential e raised to power minus x dx. We have exponential minus x all over. The coefficient of x here is what? Minus 1. So we have minus 1 plus c. So these are the rules of integration. So in my next video, I'll be talking about the methods of integration. Stay tuned so that you learn from that video. Thank you for watching. Please don't forget to like, share, and subscribe. I'll see you in my next video.